So we're going to talk about parameter changes. So let me zoom in. Hopefully you have the same graphing paper that I have. And we're going to talk parameter changes. So I want to start off with something called the parent function. So the parent function of linear equations. All right. Now I'm a parent, so I'm allowed to say the next things I'm about to say. First off, I'm going to tell you that the parent function looks like this. Y equals x. All right. So some things to note. First off, if I were to graph this, it would be linear. Well, I'm going to tell you that this graph is very plain Jane. There is not much going on with that. It is very simple. Y equals x. Oh my gosh, that's so simple. Oh, here we go. It's kinda boring. Now, all my English people out there are like, kinda is not a word. Well, it kinda is. In math week, we're going to use it. It is very basic. The parent function is plain, it's simple, it's boring, it's very, very basic. Y equals x. Hello. There's not much to that. If I were to graph that, it would look like this. It would go through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1. It would go right like that. I'm going to connect it. I'm going to make a line. This is the parent function. Now, what does that mean? Parent functions are where everything starts. I start with this, and then I can add things to it. So, for instance, let me clear this out. I can do this. I can say y equals x, and I can graph it. Okay, there it is. I can change it. I could say y equals, and I could say like x plus 3 or something like that. Now, my parent function has had a baby, and the baby is y equals x plus 3. And when I graph it, it's just going to move it around. I could take y equals x, and I could make it be, well, let me get down there to it. I could say 2x minus 9. So now I started with the parent function and I changed it now. I added a 2 and I did a negative 9. I could graph it. And again, it's just going to move it around a little bit. And these are what we call parameter changes. I'm moving this linear equation around. I start with the parent function and then I modify it. I change it. I move it around. That's what we're talking about today. These are called parameter changes. All right, now while there's a parent function for linear equations, I'm going to show you another one. That is another parent function. The parent function for, now I'm going to throw a $10 word at you here. It's called quadratic equations. I think I can make that fit right here. All right, so I'm going to give you the parent function for oh, I didn't spell that right. Quadratic equations. Hopefully you can get all that in there. Now, again, it's going to be very simple. It's y equals x, but this time to make it a quadratic, I'm going to put a tiny little 2 up there in the exponent spot. Now, just like before, this parent function is very plain. Y equals x squared. That's it. That's all there is to it. It's very simple. And as you guessed, it's kind of boring. It's also very basic. Okay, very simple. Now, I'm going to graph this one so you can see what it looks like. It goes through 0, 0. If x is 1, y is 1. But if x is negative 1, y is positive 1 again. If x is 2, y is 1, 2, 3, 4. And then it has a mirror image over here. So this looks like this. This has a name. It's called a quadratic. But we actually call that graph, and I'm just going to write it down here, a parabola. It's just a form of a name for the graph. On the same note over here, I could say this is a line. We call this a straight line, linear. This is just what we call a parabola. So the parent function for quadratics looks like a happy face. It's a big smile. Now what I'm going to do is I'm going to focus on linear, but I wanted to show you this one because they go hand in hand. When you see one movement, you can understand the other one pretty easy. All right, so here we go. So I'm going to take a situation, and I'm going to take my parent function, and I'm going to say, what if I took the parent function and I said f of x plus k? You're already like, what? Okay, let me give you an example on this. So what if I took the parent function, and again, the parent function is y equals x. Remember, f of x is just a super fancy way of saying y. What if f of x had a baby, and the new baby is g of x, and it is f of x plus 3. So I took my plain and simple and boring little function, and I added k to it, which in this case is 3. What would happen? So here's what I'm going to do. I'm going to go to my calculator. I'm going to go to y equals. Now I know not everybody has a calculator handy, so I'm going to do it all on here. And I'm going to say y equals x. But I want to compare that to y equals x plus 3. I want to know what happens. So there's my parent function going through the origin. What happens with the red one? Can you tell? I'm going to zoom in just a little bit. Can you tell that it moved up 1, 2, it moved up 3 units. So what can you tell me about that plus 3? What does that plus 3 do? It makes it move up or down. It's what we call a vertical shift. So I'm going to come over here and I'm going to graph the parent function in blue, just like my calculator did. I'm going to try and keep those colors the same. And then what happened was when I added that plus 3, 1, 2, 3, it moved it up 3. Everything else stayed the same, didn't it? The slope, the slant, whatever you want to call it, everything else stayed the same. So what I'm going to say is that what happened, let's put results. Okay, let's put, here's the results. That it moved, let's say g of x. G of x moved up 3 units. Or, let's say it another way. Oh, let me go. G of x, this is a little more mathy way. Translated just means you moved. We moved from Denton to Louisville. Yeah, we translated from Denton to Louisville. Sounds more mathy when you use translated. Up 3 units. All right, so when we add something to the end, it moves up. What do you think would happen if we subtracted something from the end? Let's look. Let's go to y equals, and let's go here. Instead of adding, let's subtract. And let's graph it. You're probably already thinking, oh, Miss Dean, it's just going to move down. Let's see. Oh, looky there. You were right. It just moves down. Okay, so if I subtract negative x, it just moves it down. So it's safe to say that the result is when you have plus k, when you add something to the end, you move it up or down. In fact, let's do this. Let's move up or down. This is what we call a vertical movement. Okay. Let's go right here and let's say a vertical translation. And I'm going to put a little bubble around it. When you have plus k on the end, you promote a vertical translation. Okay, I want to do this again over here, and I want to try this quadratic. So let's try this, f of x plus k. And I'm going to give you an example. I'm going to give you f of x equals x squared, has a baby g of x, and let's say x squared, but this time, you know what, let's do a minus. Let's do minus 5. And what we want to do are, what are the results? What happens when we do this? Okay, so let's go to our calculator. Let's go to y equals, let's clear it out. And let's put in x squared. And then let's put in x squared minus 5. And let's graph it. Parent equation, plain, simple, boring. Oh, what do you see? What do you see? Sure enough, there it is. It moved down. How many units? Can you tell? 1, 2, 3, 4, and 5 units down. So all it did was move it down 5 units. So I'm going to come here and go 1, 2, 3, 4, 5. And then other than that, it still looks the same. So I'm going to put that arrow again. And I'm going to say up and down. And we're going to write, you know what, the exact same thing. G of x moved down. I'm going to underline the word down 5 units. Or, and then we're going to use our mathy language. We're going to say G of x translated down. I'm going to underline the word down 5 units. So again, whenever I add something on the end, either a minus 5 or a plus 3, when I put something on the end, that just moves it up or down. It's a vertical translation. Okay, and I'm going to even write that here. I'm going to highlight that. Vertical translation, up and down, up and down. Vertical means up and down. All right, what do you think I'm going to do next? We did a little vertical translation. Time to do, if we're not vertical, we are horizontal, side to side. So here we go. So we're going to come down here. We're going to say, what if I do f of x, but I'm going to leave a little space here, and I'm going to say plus k. What does that mean? All right, so let me give you an example, because you're already looking at that like, oh, I don't understand that, Ms. Dean. All right, so here's an example. Parent function, we always start with the parent function. We're starting here because it's going to have a baby, and the baby is going to look different than the parent. Although a lot of times people say, oh my gosh, you look just like your mom or dad. Well, you know what? Linear equations, they're all straight lines. They look like their mom or dad. Okay, now this is going to be written a little different. G of x is our parent function, which is f, but I'm going to leave a little bit of space here. What I want to do is take f of x, and I want to add something to it. I'm going to put, let's put 2. Okay, so there it is. G of x is f of x plus 2. What if I take this and I add 2 to it? Now this looks a little different, and I'm not going to use my calculator. I'm actually just going to graph this by hand. I know that f of x and x, it's going to look like this. It's the parent function. It's plain, it's simple, it's boring. It goes to the origin. It's a direct variation. But I need to know, what are the results of this, because I'm not real good at looking at this. I can't tell. So here's what this says. This says that when I move, and I'm going to put a little bracket here, I'm going to say move with the x. In other words, if I was thinking about it and I made my little heart, right? Looks like a heart, right? My x is in love with the 2. They're together. They're with each other. They're happy. They're in parentheses together. I am moving with the x. This one up here, I don't have parentheses. I'm not moving with the x. I'm just out here chilling, being all cool on my own. This one is with the x. When you have parentheses, you are with the x. Now, here's my scenario. Okay, you go to the mall and you see your ex. And your ex is with someone. And you're like, what? Why are you over there with them? You're supposed to be with me. So you go to school the next day and you see him. And you go up to him and you say, hey, so I saw you at the mall. You were with so-and-so. And they say, I wasn't with so-and-so. Oh, y'all, my snake just came out of its cage. That's scary. Anyway, you were with them. I saw them. And they're going to be like, I wasn't there. And you're like, but I saw you. So here's what I'm getting at. Exes, sometimes they don't tell us the truth, do they? Sometimes they lie to us. In math, when you're moving with the x, exes lie to you and they say, I wasn't at the mall, and you're like, yes you were, and they're like, no I wasn't, because they're going to lie to us. So here's what this says. I already established from up above that this is going to be a horizontal movement, horizontal translation. Okay, if I'm moving with the x, it is going to be a horizontal translation because this is the x-axis, right? This is the x-axis. This moves horizontally. It says I'm going to start at the origin and I'm going to move positive 2. But here's what I know. X's lie. We're going to put this right here. X lies. It's very important that we remember that. It says it's moving positive 2, but you know what? He's not. He's moving negative 2 horizontally because I'm in the parentheses, negative 2. I'm going to shift over there. Other than that, it's going to look exactly the same. So what's the results? I'm going to say g of x moved. It says it's moving positive, which would be to the right, but I know x is lie, and so it's moving to the left. So it moved left 2 units. Or, let's use our mathy words, g of x translated left 2 units. All right, so just remember, x lies. When you are in the parentheses, x is lying. He's not doing what he says he's going to do. Okay, I want to take a second. Let's see if you got it, because if you can do it with my quadratic equations, then you got it. F of x plus k. All right, so let's put our examples. F of x equals x squared. Remember, that's my parent function. Going to have a baby, g of x, and it's going to be f of, and we're going to do x, we did plus over here, so let's do minus 4. Put it there. All right, so here we go. So let's write our results. I'm moving and I notice here, oh look, I've got parentheses. My little x is in love. He's together with the negative 4, but x is live. So let me graph it. There he is. What's my new equation? Well, it says it's moving negative 4. 1, 2, 3, 4. But wait! He's with the x. X is lying. He's really moving positive 4. 1, 2, 3, 4 right here. Other than that, he looks the same. No big changes. There we go. So what's the result? G of x moved. It says negative left, but I know it was positive right. Moved right 4 units. Or g of x translated right 4 units. So if you can understand this, then you definitely understand this. So let's put on this one, x always lies. X always lies. And I'm going to come back over here and I'm going to highlight horizontal translation. Okay. And I will put, oh, let me grab a blue. Let's put, what did I put? Oh, I just put it up here. I was trying to make sure. So I'm going to put left and right. All right, horizontal is our left and right. So let me pull it back so you can kind of see what this looks like in case you didn't get any of it and you need to copy it. So if you need to pause your video there to make sure you got everything, you can do that. Now what I'm going to do, now that you've done that, I'm going to take this and I'm going to do the back side of that piece of paper. Now, mine, it's not too bad. I didn't go through too much, but I don't like to write on the back. So I'm going to actually just use the same. If I were to turn it over, I think it would still work. All right, so let me zoom in. Oh, that zoomed in a lot. Let's look at something else. Let's look at something called a reflection. So, for reflection, I'm going to take f of x equals x, that's my parent function, and g of x is just going to be changing the sign on x. We're going to take it from positive 1 to negative 1. So take a second. We're going to put this in our calculator. We're going to say y equals. Anybody have any thoughts on that? What does reflection mean? When you hear the word reflection, what do you think of? Maybe you like a reflection in the mirror. All right, so let's graph it. There's my parent function. What did it do? Yeah, it reflected it over the y-axis. It was just like, bloop. Here's my y-axis, and it was here, and it flip-flopped over there. So I'm going to say that the results and I'm going to put here and it ended up doing this. See if I can draw that. You know what? I didn't think about it, but let's label that g of x. I should have done that earlier too. And this is f of x. And you might even go back on your other papers and label them so that you have them. So the result is that g of x, and we're going to call this reflection, reflected over the y-axis. Okay? It reflected over the y-axis. Now, if I did this with a quadratic, it would be the same thing. It would be going up this way, and when I reflect it, it would be going down. That's all it does. It just flips it. When you change the sign, it is a reflection. Okay? I want to do another one, and that is, what if we have f of x, and we put, we're going to put an a in front of it. A times f of x. All right. So let's give an example. Let's do, if we had f of x equals x and g of x equals, we'll do 3 times x. Okay, so let's get our calculator and we want to know what are the results. So take a second, if you're watching this at class or at home, go ahead and graph them, like pause the video and graph it. If you don't have a calculator, stay with me. We're going to do it here. I'm going to put my x in, and then I'm going to put my 3x in. I'm going to hit graph, and we're going to take a second. We're going to look at this. I'm going to give you a second to graph them. I'm going to graph, and you graph. There they are. And then you notice that this one is a little bit, wonder what word we're going to use to describe that. So I'm looking at that and I notice that g of x is steeper. Here's my parent function, g of x got steeper. Okay, So let's say, what is the result? G of x got steeper. That's the word I want to use. I'm going to underline that. That's my vocabulary. Steeper. So I'm going to throw, I don't know if purple will show up, but I'm going to throw h of x out here. What if I had 1/2 x? Let's just see what happens. Let's just take a look. Y equals, I'm going to come down here, alpha y equals, and I'm going to do 1/2 x. What do you think? Oh, you can't see it. What do you think? Obviously something's going to happen or it wouldn't have done it, right? Oh, what do you notice? Yeah, now h of x is less steep. So let's put that here. Let's graph it here. And I'm going to use purple still. H of x got less steep. So here's what we need to notice. On this one, when x is greater than 1, okay? When x is bigger than 1. And on that, I'm not going to worry about the negative. So we could say, how do you want to say that? We'll just say when x is greater than 1. We could say the absolute value of x. I guess that would work too. But when x right here is, it could be -4, -5, -6, or it could be 2, 3, 4, 5, 100, a million, or 1.2. It just has to be bigger than the number 1. I'm going to go ahead and put the absolute value just so you don't forget that it can be any number. Then we're going to get steeper. But when 0 is less than x is less than 1, when x is a fraction, like 1/2, 3/4, 5/6, 7/8, anything like that, then it's going to get less steep. Here's how I remember it. I just say fractions make my head hurt. Okay, they make my head hurt. And I want to lay my head down. Fractions make my head hurt, and they make me want to lay my head down. If I'm laying my head down, I am getting less steep. So I'm going to put less steep. That's how I remember it. Fractions make my head hurt. And we may want to go ahead and put the absolute value right here too. Some of you may be like, I'm not sure I'm following that absolute value part. Ask me about it in class and I'll go back over that. All right, so let's say we've got reflection, we've got steep, less steep. Another word sometimes that we use for less steep is compress. Compressed. Think about it like this. If you take a Coke can and you smush it down and you compress it down, that would be getting lower. You're compressing it. Another word that we use for steeper is stretch. Think about it like this. I'm taking my blue line and I'm stretching it. It's the red one. I'm stretching it more steep. This one, I'm compressing it down. I'm pushing it down. Compressed is pushing down. Steeper is you're stretching it and getting it steeper. Okay, so here's what I'm going to do. I think that's all the ones I wanted to show y'all. So it's time to practice what we've learned. All right, so I'm going to put like a squiggle line here. All right, here we go. I'm going to give you the parent function. And I'm going to give you the kiddo, the g of x, the transformation. Here it is. I want you to tell me what are the results. Okay, I'm going to give you just a minute to look at that. All right, so here we go. Let's put these results. Now, I'm not going to try and graph it I'm just going to talk about the results. I just want you to look and be able to tell me what happened. If you put it in your calculator, let's go and put it in there. So there it is. When I go to graph it, and this is why I don't really want you to graph it, it kind of looks kind of interesting there.
Is cube left fixed?
Yes, it is. So here's what we're going to say. We're going to take it piece by piece. I'm going to tell you that there are 3 things that happen. I'm going to look at that 3 first on the end. That means it's a vertical. It's out here by itself. That means I'm moving up and down all by myself. So this is going to be that it moves or translates, moves up 3 units. Usually you just say units. If you say moves up 3, that's okay. Now I'm going to look at this lovely little couple here in the middle. They're moving together. They're with the X. It says it's moving negative, but I know it's moving positive. So it's going to move or translate to the right 2 units. Now I'm going to look at this 3 right here. I know that the 3 is bigger than 1, so that means it's getting steeper. On my graph, I can see that it's getting steeper. So I'm going to say it gets steeper by a factor of 3. Okay, whatever that number is here, that's what I'm getting steeper by. Okay, now let's look at another one. What if I take the parent function and I say take g of x, and let's see what happened. Let's do negative 3x minus 1. Okay? What are the results? All right, I'm going to tell you there are 1, 2, 3 things that happen on this one. I'm going to give you about another 10 seconds. All right, I'm going to do this negative 1. Negative 1, it's hanging out on the end. It's all by itself. There's no parentheses. There's no movement with the X. This is out here on its own. So this moves or translates down 1 unit. Now I'm going to look at that negative right there. What does that negative do? You remember what we called that? That reflects over the y-axis. And the last thing I'm going to look at, yep, that 3 right there. You know what we're going to do? We're going to do a little quick fix. We're going to change that to 1 over 3. We're going to make that into a fraction. Oh, what does that 1/3 do? 1/3 is a fraction. Oh, fractions make my head hurt. So this gets less steep or compresses by a factor of 1/3. There we go. That fraction right there makes it compress down. Okay, so I think you got it. So here we go. Let me give you another one. F of x equals, I'm going to look at my notes here because I may do another one. Let's do, oh yeah, let's do this. Oh, I forgot about that. Okay, I'm going to flip it on you this time. Ready? I'm going to still do f of x. So we're going to say that this is my parent function. So f of x equals x squared. G of x equals all right, can you write g of x? First off, which way am I moving? Up and down, left and right, vertical, horizontal, what am I doing? Yeah, this is a horizontal movement. How much? Right here is where I started. 1, 2, 3, 4. So I moved over 4. Okay, so if I'm moving with the x, if I'm moving horizontally on the x-axis, that means I need to have parentheses. I'm going to put my little 2, I'm going to put it right here. So I need to say x, it's 4. The question is it plus 4? Because it's plus 4 over here, or is it minus 4? I'm moving in my parentheses with my little buddy, the x. X always lies, but I'm moving with him, so I'm going to say minus 4. Now here's what I want you to do. I want you to write h of x, and I want you to translate g of x down 1, 2, 3, 4. So there we go. I know that's not the prettiest picture. Move it down 4. H of x is g of x translated down 4. Well, all I need to do is take g of x, which is x minus 4 squared, and I need to move it down 4 units. There we go. All right, so I think you probably got it. Thanks for watching. I hope this helps you with your parameter changes. That'll be coming up soon on your test.